Good day and welcome to this lecture on how to do steel reinforcing rebar bending schedules for concrete. And we're going to be doing it using AutoCAD and Excel. This is a basic introduction into what bending schedules are and how to do them. So first we'll look at what is rebar, what is reinforcing steel, where do you put it in steel and in concrete structures, and how do you put it in. Then what is a bending schedule, how do you consider it, how do you draw it, and then we'll go through drawing them in AutoCAD, creating a schedule in Excel, placing it in AutoCAD, and just general guidance regarding doing all sorts of things. But first what we're going to do is start out looking at some photos of steel reinforcing or rebar. Now, on this site you can see they've just started construction, they've cast some foundations. What you have in front of you here is various piles of rebar that they've prefixed. So the steel, the rebar, the deformed bars will arrive on site, and then the workers will fix it together and then put it in place. So often you prefix things on the ground and then you lift it in place. So here you've got a column that's going up, here you have some bases on the right. These bases will be dropped in the ground, have shutters put around them, and then the concrete cast. The bases will have starter bars sticking out the top. And here at the back you can see there's some piles of rebar going around. So when you think about this can give you a feeling for how all rebar actually happens and how it goes into place. For many elements, so if they get to bigger, more complicated things, then they'll fix them in place. They won't create a unit and then drop the unit in place. A couple of things to notice while you're looking at this. You can see these rebar bars here have been cranked inwards, so to allow the next rebar, the next lift that goes on top to fit around it. You can see the different shaped stirrups going around these columns, bases, how they look. So you get various different things you have to consider. Now these are some columns that are being built. You can see the starter bars sticking out here at the bottom. So these starter bars are cast with the base and then stick out. You'll see it on some more slides. Here's some rebar going in. This is a big ground beam. So you've got some piles in the ground with this beam on top. So what you have to imagine is the guys on site that have to fix this, can you give them enough information that they know what piece of steel to put where? If it's too complicated, you're going to have problems, but you also, if it's too simple, you might have waste and it can be uneconomical. So there is a balance, but generally you want it to be quite straightforward, because you can imagine this becomes quite complicated when you've got various pieces that fix to each other. Here's another piece. You can just see some bars lying around, so you need to be careful of how they manage them. You can see here's a big open base. There's the piles and the pile rebar sticking out. And they will use these bars here, and they'll fix these in the hole. Here's some plinths or some little columns sticking out the ground, which have been cast. There's rebar in there. And then there's going to be a big base going at the back there, which I'll show you now. There you go. Here's a big hole. And you can see them fixing this hole. So there's around with this, and they're busy fixing it, and then they're starting, and then they'll pour concrete in this to create the reinforced concrete system. So keep thinking at the back of your mind, how are you actually going to build this, and how are you going to fix this? So imagine if you give them a mesh here that is very, very difficult to fix. They might not do it properly, or it's just done badly, or it can lead to all sorts of problems here. For instance, you might not be able to see this clearly, but there's a column as part of the wall. It becomes quite difficult fixing these sorts of things. You need to consider them when you do your stirrups and all sorts of other things. Here's the starter bars sticking out of the base that's been cast. What you do, these stirrups are sort of rectangular together, often a little bit smaller than they need to be, just so that your starter bars are pulled inwards on the first cast. So when the next rebar comes, it can fit over that. But it depends on what you're doing. Sometimes you otherwise crank your first column lift of rebar inwards, and it fits inside your starter bars. Here we go. Here's multiple starter bars on a base. You'll remove those fixing links, then you start your next lifts. And here's some rebar here. There you can see that the starter bars have been removed, the base has been cast. Okay, let's start having a look at a bending schedule and seeing what is it that contains this information. Here's a quick bending schedule I'm going to show you as an example. We've got various ones. Here's an example of some starter bars. So you can just see a column here with starters coming out the top. And there's starters coming out the top. You can see it's been pulled in a little bit so that this will fit inside the next lift. Fixing links. Then you can get to very complicated rebar schedules like this. And this is for an entire slab. So you'd have, this is your bottom fixing, this is your top fixing, so you need to write all the information needed for the whole area. And then you'd have a separate schedule. You go to refer to those schedules to find the actual bar information. So this would be your fixing plan, and then you'd have a separate schedule. The bars we're looking at are made up of these sort of different types of bars. As you can see, there's various different bars you can use. We're going to start going through these as we create the schedule. But what you need to do is have standardized bars so that you can give an instruction to the bending yard, the place which produces the steel and bends it to the shape you want. Your standard codes, for instance, this is a shape code 60. And then if you tell them it's a shape code 60 with this, an A dimension of such and such and a B dimension of such and such, they know what to do. I just want to actually open another bending schedule for you so you can have a look at it. Because what we're about to do is actually create an entire bending schedule from scratch and then produce something that you can use in practice. So this is the example bending schedule we're going to create. This is a base type A. At the top you can see here's all your sort of schedule information, all the bar dimensions, etc. Here's your fixing plan, so they can use these bars in this table up here, and then they know what those dimensions are, and they can come here and then they can fix it. And then there's various instructions and general information at the bottom. We're going to swap over now to AutoCAD to start doing it. But the way we're going to be doing this bending schedule today is we're going to be switching between AutoCAD to actually draw it. And this schedule we're going to generate in Excel. Yep, here you go. Here's the Excel schedule, which we will use to create the schedule and produce all the dimensions. Here you go. This is a spreadsheet we've produced, which we will provide to students and such, and they put online for everyone. So this gives you all the information about when you enter information to the sheet, it generates the various details, couplings, tonnages that you need, and you can copy and paste this into Excel. Right, now let's go back and start getting a better feeling for the bending schedule and what it is and what it has on it. First, what you see there is the layout. This needs to give details on how to put the bars together. So if we look on this, see we've got a bar, just clicked on it, that cyan bar there, and that's got specific information, and you can see it's number 2, it's labeled number 2, so that means it's bar mark 2. And the guys on site will know, okay, there's a line going from there to there, which means they fix lines from there to there. You'll see on our schedule, you don't have that second line, the brown inner line. I use that just for construction, just while we're creating the layout to speed things up, and then I hide it. I'm just going to hide it now so you can't see it. What we're doing today, we're going to show you the basics of using AutoCAD, but it is assumed that you have some basis in AutoCAD and you can read. If you can't, there are other lectures online. Here's a couple you can go use: an introduction to AutoCAD and structure drafting for civil engineers. And there's 6 lessons online that you can go look at, which will take you through all the general tools and tips and tricks for using AutoCAD. And we also have a video on how to analyze and design a structure. So these will help you in various structural engineering topics. The structural engineering is more for steel structures, but it does also cover some concrete things. But these ones below will provide you all the drafting information you need on how to use AutoCAD. Now, let's start having a look at A bar, and then we're going to see why we draw it, how we draw it. Okay, here we've got A bar, shaped like this. What we're looking at is almost a section through it. In real life, here, the section AA. I'm just going to change that. That should be AA. So section AA through here, and section AA here. And this is how it would actually fix. This bar here, click on it. This bar here is this bar at the bottom. And in section, it lies on the bottom and then loops around to the top. And this provides your strength in the bottom such that as this base bends and there's pressure from the bottom pushing upwards due to the loads coming down, it pushes back up, and then this bottom steel resists the bending moment in it. So this provides the tensile strength in the bottom of the slab, so it spreads the load. And these bars in this direction provides bending strength along this axis. So anything pushing from this side, from the top, and bending it in, these will provide resistance to either the bottom or the top. Often for a base you only need bottom rebar. For now we've shown you one with bottom and top, but you just need to see what the requirements of each base are. Now let's come back to this bar. You can see there's a 2. That means it's bar mark 2. So now here we have an instruction which gives details around what this bar means. Well, firstly it says 7 Y16 02 200 B1. The 7 means that there are 7 bars. So they'll go 1, 2, 3, 4, 5, 6, 7. There are 7 bars to go from one side to the other. Y16 is Y means that it's high tensile. R means it's mild steel, but that varies from country to country. Y and R are what we use in South Africa. So it's a 16mm diameter bar. It's bar mark 2. This 02 means it corresponds to something in this table. Here we go. Bar mark 2. It's 16. There are 2 of them. Number of members, there are 2. So there are 2 bases. For each base, you need 7 bars. And I've got bars in each is 7. Then, so there are 14 total. That's simply these 2 columns multiplied by each other. The cut length then, that is the physical length from start to finish. So all the way from start, all the way right around, including bends, including everything else, gives you a total cut length of the following. That's the shape code I was talking about later. So this is a shape code 38, which means if we go to the schedule, so it's shape code 38, so it's something shaped like that. It's a U-bar. If you look at let's say, oops. Sorry, I was looking at the wrong one. Shape code 2 is a 55. The bar mark 3 is a 38, and bar mark 1 is a 38. So bar mark 2 we were looking at is a shape code 55. Just going to find shape code 55. There we go. So it's got an A, B, C, D, and E. This E dimension, whenever you have a dimension in brackets on this schedule, it means that you don't show it in the column. So you've got A, B, C, D, E. You can see the E value is not listed. The E value is actually determined by your cut length, and then they cut this length on site or in the bending yard, and they bend the following dimensions, and whatever is left over becomes E. Because you might provide an E, and if they have different radius bends, they'll actually end up with either a different cut length or with a different E, depending on how you work it out. So that's why you provide certain dimensions, and then you work out your cut length rather than putting in all the dimensions here. Normally on the schedules, these tables, they don't give you the bracket I've shown here in the details and brackets. They don't normally provide you with. Alright, but let's start now going through what we would do. So here we've got it's bar mark 2, Y16, and then all these dimensions. So it's a shape code 55, A, B, C, D. So here we go. If we look at this, I'm just going to do a dimension. So here we go, that dimension A, and our shape code 55 here is A. There we go, A, B, C, D, E. Now it's normally better if you draw these to scale. It's possible to not draw them to scale, but you make possible to make a lot more mistakes. Here we go. So there's your B dimension of 200, your C dimension of 1800, etc., etc. So you go through and work these dimensions out. And I'll show you just now how to work those dimensions out for each type of bar. And then you'd have a look. Here we go. There's the other bars, etc. Now let's come back to this. So we've got 7 Y16 bars, so high tensile steel bars. The bar mark 2. So if I go up here, I can find bar mark 2, and it'll give me all the dimensions for the sort of sizing and spacing. This thing now, the 200, that's how far apart they are. So if I go back to my picture, let's say it would be how far are these bars apart in this cage. So this might be a 150, 200, 175. You normally want to keep it in increments of about 25 millimeters. Giving them a dimension of 152 becomes quite difficult. So they have to space it out inside. So normally round off to the nearest 25 mils or 20 mils for spacing. So you have Y16s at 150, 175, 200, etc. Now let's come and have a look at the last term, so the B1. B1 corresponds to this table. It explains what it is. Bottom, B, T, top. B1 means it's the first lowest bar. It's on the very bottom. The B2 layer is on top. The same thing, the T1 is the outermost, the very highest layer, and then the T1 is the top. So if we look at this, this is our T1 layer on top. This will be our T2 layer, B1, so it's B1 at the bottom, T1 at the top, and then B2 and T2. So the inner layers are the 2 layers, the outer layers are the 1 layers. So there we go. So that's 7x16s 02200 B1, and then obviously 7x12s 01200. That's a 12mm bar, and that fits on top. The reason it's done like this, so you can come drop in these bottom bars, and then fix the bars in the other direction and come put the bars on top. You could make this as one link, as one continuous shape code 60 all the way around. It just becomes more difficult to fix, but it might use a bit less steel, so certain structures would do that, certainly won't. But what we've done here, it also means that we only need less steel on top. We use 12s on tops and 16s on the bottom, but you have to look at each structure. The rebar sizes I'm showing you, I haven't specifically designed these at this space. I've just used these as an example of sizes. So there isn't particular reasons, but this is approximate rebar that you might get in a typical base. Here, if we look at the other directions, we've got 10, Y12, bar mark 3 at 200 space, T2 and D2, ABR. Now, ABR means alternating bars reversed. That means I'll put my first one facing this direction, and the next one facing that direction, this direction. And so you swap the direction each time. It's quite commonly done, so you don't have all your joints and your links in the same place. You stagger those joints throughout. And then T2 and D2 means it's the same bar top and bottom. That's why I don't have a number here. If it's obvious that these are the same bars, then you don't need to label it. Otherwise, you might need to label which one is which, using 1s and 2s and whatever other bar marks you use. The bar mark doesn't necessarily have to be sequential. I could have 1, 10, 50, 200. But you want to keep it easy. Otherwise, what helps is if you put them in a group. So 1 to 10 would be for the plinth, and then 20 to 30 would be for the base. Then it's easier for the guys to find where it is. And you can even divide off sections. You can add a box here and say this rebar is for the following, and this rebar is for the beam. So there are ways and means of trying to make it simpler for the guys on site. So now we'll have a look at how these bars work. But there's also a couple of other details we provide on this. This is the column or the plinth. So we've provided starter bars. So this little plinth in the middle there fits up here, and we've provided details. The 5 and 6 means it's bar mark 5 and bar mark 6. There we go, bar mark 5, bar mark 6. It's got various information. And those are once again shown on the section through. So you want to give them a section through. So if there is any confusion in the space, they can go to the section. A base like this, you possibly don't need a section, but it's good to put it in. And here we go, we've got 4 Y16s, bar mark 5 starters, so these are starters, and then you've got 2 Y12 starters. So this is on a 250 by 460 column, section AA. A couple of other information to note. Make sure you have a big label saying what base it is, base type A, base type E1, or pile cap A, cotton beam 16, whatever it is, so they can easily see where the structure this fits, because they should have a concrete plan, which then helps them locate where that is. You should give them how many there are of them. So if there's 2 or 10 or 20 of these same bases, that they can also know how many schedules there are. And then what's also a good idea, if there's lots of numbers, you might even want to add base number 16, 32, C16. If they're base numbers on your concrete drawing, it's easier if you give them a list of where these bases go, or grid line A5, G16. So it's much easier for them to find where this all fits together. Alright, in other information, not particularly at the moment, so that gives some basic details in terms of this schedule. Now let's have a look at this bottom area. Firstly, what you need to do is give them a reference. So here we go, for location of rebar, refer to drawing number whatever. So this would give them a reference of where do they find this concrete drawing to know where these bases go. And you should make that accurate and obvious. These are just then general notes. So supply comply with SANS 282, the code. Stools to sit on B1 and support T2 layer. Stools are these funny shaped things. They look like this. It's a shape code 83, something like that. It sits up, so it's a little top hat thing that supports the layer. So I'm going to go to my photos. A stool will sit on the bottom layer and then go all the way up to the top. So that on big bases, these don't sag here. On smaller bases, it's normally fine. For instance, as you've seen, I've labeled them this and actually so that you should add 2 whiting bar mark for a meter stools center to center each way. So at 1 meter centers in every direction, we want to add stools. So that's one way of doing this. You can do the same with clips. If you've got a wall, if you go back to the wall here, that wall there will have little clips, so it's bars the same width as the wall, and you can use that to make sure that the wall rebar, the inner face and outer face, stay the same distance apart throughout. So if it's only fixed at the bottom, fixed at the top, the 2 meshes of rebar become separate. So you want to add something just to hold these together. Alright. Now continuing back to this schedule we're looking at, it should have various abbreviations to explain what's what. So we have explain B1, T1, EF each face, FF far face, NF near face, each way, staggered, alternating bars reversed. So remember those things, make it clear, make it obvious on your schedule. You also need to provide what provision date it is, what happened with that provision, if there changes. Give them a lap length. We're using 50 diameters, but sometimes you can actually go below that. The cover, what's the concrete cover? So that's the distance between the outer face of the rebar, the outer face of the rebar here, and the outer face of the concrete, how much concrete cover you have. Then, yeah, that's 15 mils to the base, 25 mils to the plinth. The mass, here's the total mass of the schedule. So for 2 bases, with this the rebar, it comes to 149 kilograms. The spreadsheet will then look at work it. Give them the project name, details, drawing, base type A, give them the base size, the column size, etc., who drew it, approved, etc., job number, etc., the company name, it's the company, and all the general details on it. So that gives you what you need. Alright, let's start now drawing out one of these schedules and actually creating what we need so you can get a feel for how you put this together. So let me copy this across and delete off some of the information. So I'm just going to type CO for copy, enter, click, move this across. As I said, refer to the AutoCAD lectures if you want to go through all the tools. I'm just going to delete this off altogether. And delete this, some of it I won't have time to do now, but I just want to give you a feel for what you might want to do. So I'm going to even delete this schedule at the top. I'm going to now start drawing this schedule and this base. Now it's a 1900 by 1300 by 300 feet base. So I'm going to draw a plan view. Go to home. I'm going to go draw a rectangle. There's my rectangle. Click. Press D for dimension. 1900. Enter, 1300, enter, and I've got my rectangle. I need to make sure this is on the right layer, so I'm going to change it to structural element concrete. You may have different things. The color in AutoCAD maps to specific line thickness. So I've drawn this as red, and here you go. My red line is quite thin, 0.18. Yellow's a bit thicker, green, cyan's much thicker. So you can see you use different thicknesses for different things. Normally on a concrete drawing, the actual concrete lines would be quite thick, they'd be green or cyan. But on a rebar schedule, your rebar is actually the thick line. You want your rebar to stand out. So if we look at this, you can see the rebar is a thicker line, whereas the concrete is a much thinner line all the way around. So that's why we're using cyan for the rebar and red for the others. It depends. The companies you use at the colors you use at your company may be different. Each company normally has their own standards. So just see what file you are using. Alright, so let's start creating this view. So what I'm going to do now is draw in the plinth in the middle. I'm going to add the 230 by 460. So click D, enter for dimension, 460, enter, 230, enter. There we go. I'm going to click on this and move it. So click, type M for move, enter, or I can use the move tool up here and enter. and then I move this across. Yep, and then I'm just going to move this down to be in the center, so I'll get my center point. And sometimes it's works at the so it's now on the center point. This base has 50 mils of cover to it. Right, before I do that, sorry, let me just, one good practice is match the properties. So I've just drawn something and make sure that they're both on the same layer. Now I want to draw my cover in. So I've got something to make life easier when I draw. We've got 50 mils of cover, so I'm going to type offset. Then it says specify offset distance. I'm going to type 50 for offset distance. Click on my base. Click on the inside, and there we go. There I've got my offset distance. Now this I'm going to create on a layer called hidden construction lines. So I'm going to turn on that. It's going to eject because that layer is turned off right now. I'm going to go turn that layer on. There we go. So the layer is now turned on. So this is very useful now for drawing. So I can use that to draw 2. Now let's put in that first bar, this bar mark 2. These dimensions of these hook backs will depend on what you need for anchorage. For now, we're going to make it 100 mils. This depth now is the overall depth of the slab, of the base, minus cover. So what we've got here, I'm just going to show you, we've got a 300 mil foot base. There you go. We've got 50 mils cover, 50 mils cover. So that means this central dimension is 200 mils. The other bars, since they fit inside of it, the other bars fit inside of this, it will be 300 minus 50 minus the thickness of the bar. So it's minus 16 minus 16. And you round off. Rebar you don't do to sort of millimeter accuracy, you only round off to about the closest 5 millimeters. So this shape code 55 again with it right now is 200 millimeters deep. But the bars that fit inside of it will be 200 minus 16 rounded off, so it'll be about 170 mils. Okay, but let me start drawing this. So I'm going to go polyline, PL, enter, or I can go up here, so you can see I'm going to go polyline. I'm just going to start somewhere. Let's say I need 100 mils internally, back, now I'm going to down 200, enter, draw all the way across, go up 200 mils. And then in 100 mils. Okay. Then I click on it and I make sure it's on the right layer. Structural element concrete, structural element reinforcement. And I'll change it to reinforcement. There we have it, draw our first bar. We can put a bar on top of it. We're going to put one of these, a sort of little bar with downturned ends. We could use a shape code 35. One thing though in South Africa, to bring our codes in line, the SACIA, which has said that shape codes 32, 33, 34 were removed as they're adequately covered by other shape codes. This will bring SA codes in line with British codes. So to bring the South African codes in line with the British, they're removing 32, 33, 34, 35. But I've used those shapes quite a few times, and normally people in South Africa are quite comfortable using them still, but depends to match your international standards, we don't use them. So for that reason, I'm just going to use a 38 for now, but you could use a shape code. There's a 35 without any difficulty, so I'm going to use my 38. I'm going to draw my shape code at 38. I'm going to go polyline, go up 100 millimeters, enter, all the way across, and done. Alright. And then match properties, so I click here, match properties, click on my bar and match my properties to it. Sometimes you just move this, so you click on it, click on move, and you can move this around. If you wanted things to go vertically or horizontally, exactly like they are now, you have orthos on, there's ortho, or you can turn ortho off and then you can move this in any direction. So I'm just going to move it down. Now we need to give them the dimensions. Where do we put this bar from and to? What I find is the easiest, I use a leader, and I've set up a special dimension style. So I've got 1 in 25, so this is about roughly a 1 in 25 bedding schedule on an A4. That will show that from this inside of cover to this inside of cover, there must fix bars in this zone. So I'm going to type leader, LE, enter, leader, so we'll start here, go all the way around, and turn ortho back, off, and stop. And then I need to, that's where it starts, and I'm going to put where it stops now, so add another leader. So my rebar will go from there to there. You need to say which ones are labeled, so we'll put this little green circle with a number on it. So you know, you add that circle so you make sure, in case this line crosses multiple bars, you know that it refers specifically to this bar. Now we're going to make sure these are labeled, so this is bar 2 at the bottom. Here's the top one, bar 1. Now let's give it this information. What code? How do we work out this code? So we copy this text across. Well, you copy different text across, which is wrong. And you can actually edit that. So click on it, copy, 0, enter. Otherwise, you can use the tools in home. You click on it, type copy. You can move this across. Turn off ortho. You can use otherwise F8 to turn ortho off and on. Alright, so if I've now done the design of the space, you should first do the structure design and work out how many bars you need. And I've worked out that I need arm centers at 200 millimeters apart. So I need Y16s. So okay, I'm going to put this now. Change this. I need Y16s at 200 centers. It's going to be my B1, so it's as far down as possible to get the maximum lever arm, and that's the effective depth at 200 space. Now, how many bars do I need here? Well, it depends on how far it spans. So if I go and I add a dimension from here to here, what width is that? Well, it's obviously the overall width minus the cover. So it's 1300 mils minus 50 gives me 1200. If I divide 1200 by 200, you get 6. But remember, that's 1, 2, 3, 4, 5, 6. It will stop before the last one. It breaks it into 6 increments. So you divide it by the spacing plus 1. So it's 1200 divided by 200 plus 1. The 1 is for the very last one, so you add 1 on the far side of the last zone. So it's 1200 divided by 200 plus 1 gives you 7. So I've got 716. So then it changes now to bar mark 2, B1. So that gives us that bar there. Now let's have a look at that other bar we're going to create. This one here. It's created in the other direction. So we're going to draw it out. We're going to use a polyline. Start here, draw down. Press F8 to turn off on. 100 down. Just go back up. Remember, this depth was 170 millimeters. It's 300 depth minus 50 cover minus 50 cover minus then the 16 mil bar top and bottom. So you could almost minus 12 mils because most of the area it's just 12. We're going to go 170. And then go all the way across the side here. One advantage of using less bars and you copy them so it's the same bar top and bottom is fewer bars on site. There's less confusion and it's easier to fix. We'll just match my properties now, so match. Now I'm going to copy this one across. So either I can just mirror it, so I can click mirror. Enter, I've got it down, I just need to mirror it the other way. Mirror, enter. Find a center of here, centroid mirror. Click, do you want to erase source object? Yes, enter. Okay, there's my bar. In, enter, move it across. So there's my bars. Then we put a leader, LE, enter, leader. All the way across. And on the other side, leader, enter. There we go. And we're going to add some green circles to it just so you know what bar that line is referring to. Oops, so I put it in the wrong place. Okay, so now it's labeled, and now you go and do the same thing. Y10s or 10s, Y12s, bar mark 3 at 200, T2 and D2 alternating bars reversed. So copy that, put it across here. There we go. And we go through the whole system like this and create this bending schedule such that we get all the bar information. One thing I'm just going to quickly do before we move on, I'm just going to also show you how you might create that plinth, the sort of starter bars, the column there, the 230 by 460. So I'm going to draw it out, do enter, 460, 250, enter, there it is. This has 25 millimeters of cover, so I'm going to offset it by 25 mils. I'm going to match the properties, so it's hidden. Well, this one I can actually match properly because this is going to be Revolve. But One thing you must remember is, as I showed you earlier, just going to go back to one of these pictures, if this rebar sticks out and it's the exact same place as the first lift of rebar, the rebar that sits on top of it, which looks like this, they will clash with each other, and especially with big bars. If you've got Y25s, Y32s, and maybe even Y40s, Y40s you don't often use, they're going to clash with each other. So you want to make sure that you can drop one on top of the other. So here what you can see is there's the first rebar is actually inside. So you make this cage just a little bit narrower in the one direction. So if I come to it, I'm going to move it in by click on the tag, and I move it in 15 mils. And move it in 15 mils. It should be 16 though, so you're rounding up to this millimeter. You could even move it more than that. If you're concerned that there's going to be clashes or tolerances, you can move it a bit more, give it a bit more space. If it's a structure and this column is carrying lots of bending though, I personally prefer leaving the starter bars where they are and then cranking the first lift. It really depends. One thing though that you've also got to consider with those cranking bars, if we had a beam coming across here, let's say we're going to cast a beam from this column to this column, it's also a good idea to crank your bars inwards. If you've got all your verticals coming up in the same line as your beam rebar coming across, is going to be a big clash. I'm just going to go to a schedule where they show that. So here we go. So you can see here they actually crank the rebar in to fit the next one on. Yeah, that was a beam there. That's a beam from there to there. So the bars are cranked in to allow the beam rebar pass, and then it's sticking out the top in the next lift, so that the next lift of rebar can go over it. So you cast into your beam and then into your column above the slab if you require. Right here you can see there's sections, and then there's other stirrups and various things. Okay, let's go back now. Now that we're starting to finish off our schedule, what we need to do is something like this. I like just adding little corners on it, so you can see it's a stirrup. The other way of drawing it is like as shown in the schedule. There we go, like that. If you shape it 60. So there, and then you also want to put in where all the bars are. So you make it look something like this. So you just actually copy and paste, copy over for now. Yep. And we have our schedule. I'm just going to move this down because when we copy and paste our schedule onto it, this is going to start flashing. And we're going to move it all the way around. All the way down. Now I'm going to have a look with you at this schedule for generating this information at the top, this table. This table is very easy to stuff up and make mistakes, so be careful of that. Check your schedule very carefully. Once you have generated this table, go back, print it out, go with a highlighter and check all the dimensions to know that everything's right here. The image schedule is one of those things that can very easily go wrong. Imagine now you've got a stirrup or something and you have plugged in the wrong dimension in one of these areas. It can really be a headache. It can really be a major problem that these dimensions work out incorrectly. And I'll show you actually how that might happen very easy on our schedule as we go through, as we check it. But for instance, this tool, the shape code 83, if you typed in just the wrong number here, then your stools would be all too high. If you typed in 1200 instead of 1800, your bottom bars your top bars would be too short. So you need to be very careful. It's very easy to make a mistake on a schedule because you can't see physically on a drawing what it looks like. It's just numbers. So go through, check it carefully. Every schedule you create, check it before you issue it. Right, now let's go into Excel. This is a spreadsheet we created. It's been washed. It's from my old time at BS & Baker. We started producing it there. This is it's to calculate all the information you need for the schedule. So what you need to do is you fill in the columns in green. So all these columns in green, you provide the information in those columns, and the other columns work out. There are also 3 columns here you fill in. These are the dimensions I said you don't put on the schedule. So any letter in brackets. So if we go back to our schedule, any letter in brackets, or if you on most schedules, on most bending dimensions, they simply don't give that the C dimension. They just give you the cut length. So whatever unknown dimension, they would just normally leave this dimension off altogether. But for us, if it's in brackets, we include it in this column at the side here. And also what bar type it is, if it's Y or R, and we'll work up the total tonnage of R bars and Y bars. If you want to change it, if you're overseas and want to change it to whatever, if you type M there, then everything will change. So it references that. You then obviously manually need to go change it for whichever bars you're looking. It will reference that cell there. So you can adjust the spreadsheet. We'll check it back now to Y bars, high yield, R bars for normal mild steel. And that gives the tonnage of each, total schedule mass in kilograms. This, as I said, was your ABC dimension, or the ER bar type. So it's Y or R, you fill that in. And the bar diameter, you fill in 10 mils, 12 mils, 16, 20, 25, 32, 40. Fill in all your standard bars. It doesn't work if you fill in, let's say, a 7.5 mil bar, a bar that doesn't exist. This is linked to it. The bar specifications here, primarily this high tensile is all linked to this, and it gives you various dimensions of the different bars, so it will work it out for you. Alright, now what we're going to do is start plugging in numbers. We've set up a separate sheet for it, so I'm going to swap across. I've now deleted the information, so I've made the schedule sorter. I've resaved it as the schedule. I've given it a name. That's the name of my bending schedule. It's project 1234. It's bending schedule. It's a foundation. Number 1, Reg A. So this gives you all the information you need. And we now need to get all the information into there. So now if we have that bar we were looking at earlier, and we just delete all the information of that. So you delete only the green cells. Top. So now, here we go. There were 2 bases. There were 7 of them in each, and then it'll work out that you need 14 of them. The shape code, so we go and check what shape code we need. Remember, it was a shape code 55. This one here, so it's a 55. And the A dimension was 100, B was 200, C was 1800, D was 200, E was 100. So there we go, that's a shape code 55, 100, 200, 1800, 200, and then the last one we would need to make sure that this column there has 100. And as you see, as you edit that, it updates your cut length. And the way the spreadsheet works is once you enter a shape code 55, it actually looks it up here. So it'll work out the cut length for every type of bar with those dimensions. So if it's a shape code 20, 32, etc., it plugs in the ABC values into equations and works out your cut length. All it is a lookup function, so the bar. So this cut length is a lookup. It looks up in that, all your shape codes at the top, and it looks up these values here to find out what you need. So it looks it up, and then it plugs that value in there, and it rounds it off. It rounds it off to the nearest 10 mils right now. So you divide by 10 millimeters. And then multiply by 10 millimeters. That rounds it off to the nearest 10 millimeters. Okay, and there you go. There you've got your first bar in, done. And you go through all the same with it. For instance, that stirrup we were looking at just now, remember I said you have to be careful. I've got 410 by 150. So you go back and say, then you double check, is this the right dimension? Well, it's A. Let's measure it off. Oops, annotate. Dimension. This is a 230. Okay, great. It's a 230. It's got 25 mil cover. 25 mil cover. If you draw it to scale, everything works out. And you measure this one in the middle, and you go, oops, hold on. That's 180 mils. And I've got 150 mils on my schedule. So you make sure you go back and you fix that up. And you do this with a highlighter. You check through, you make sure you pick up any possible mistakes. And even then, things can creep in around easily. There you've got 460. And then you can otherwise work it out. You say it's 460 minus your 50 mil cover. So that's 14. Minus then with 30 mils extra. So you go down. Sorry, let me go back to the right schedule. So this would otherwise be 460 minus 50 mil cover, the 25 times 2. And you write 25 times 2 minus 16 mils times 2 gives you 378. Aha! Wrong. So you need to fix that dimension. Now it shows you a very easy thing. Just by swapping those numbers around, or getting them slightly wrong, you wouldn't realize that was wrong looking at it, but you can very easily arrive on site incorrect, and then things don't fit. I've had it before that stirrups, well, stirrups are a famous one. They very easily can get drawn wrong or dimensioned wrong. And if you've got a, let's say, 600 by 600 column, and the stirrup is for a 300 by 300 column, you've got a major problem. They get to site, the rebar arrives, they're fixing it, and then the stirrups don't fit, and they have to go get more stirrups, and it's a very big delay. Everyone's shouting and screaming and complaining and blaming you as the engineer. So be very careful that you check these dimensions, because it can go wrong very easily. But then we'd go through it, or we'd add all the rest of the bars in, etc. I'm just going to show you then how you might work out some of the other cut lengths or other dimensions for this. With this bar here, we've got a starter bar with whatever anchorage you need here. And then one way of drawing this, draw a polyline, enter, draw it up. You need to go up at least your lap length. So let's say I've got now this is a Y16, so I've got 50 times 16, so it's 800 mils, up. And then I need to know go down so it sits on top of this rebar. So I'd go down 300 mils, minus the cover, minus the one rebar layer, minus the other. So let's say that works out 220 mils, 50 minus 12 minus 16 sort of thing. And then you draw your anchorage length, whatever that needs to be, depending on the bar, depending on the forces. And then you can draw this. Once you've drawn it, if it's clashing with other things, you can just move it around so you can see it clearly. But that way, then you can go and draw all the bars in, and you must label them. So you know this is 4 Y16 bar mark 5 starters, 2 Y16 starters, and then label it. If it's in section, it's Y12 bar mark 1, Y16. And you want to label as much as possible. So once again, here you label all these bottom T2 and D2. I like labeling the sections as well, just so that there's no confusion. And also, what helps is if you draw all the bars. Let's say you work out you need 10 bars there. You go through and you draw the bars. You suddenly find out, oh, if I draw 200 in the centers, 10 bars comes to here, or 10 bars comes to there. You realize that you need more bars, and you've made a mistake there. So it's one way, if you draw it in section and plan, you can double check your results. And then you basically go through this whole thing to create all these dimensions. One thing, if you're working out your stools you have to be careful of. That once again is, stools sit on B1 and support T2 layer. So to work out the stool, it would sit on this B1 and support T2. So it would be the depth of the slab minus the cover, minus your B1, minus T1, minus T2. So you go total thickness, minus cover, minus B1, minus T1, minus T2. The thickness, the diameters, and that would give you the dimension here. 155 mils in the situation, and then these dimensions here are just big enough that you can sit over more than a couple of bars, so A, C, etc. So you make the stool such that it can span across a few bars and support things. You add your section marks in, go through it all. Then once it gets to the stage where you want to add in your tonnage, you go back to the spreadsheet. This will total up the Y bar, so if it's a Y bar, the tonnage will be entered here. If it's an R bar, the tonnage will be entered here. And this will then add it in and calculate it off. And then you can plug in, this is 149 kilograms, so you can put that back into your schedule. Once again, you just want to double check that. So also, just be careful, you start playing with spreadsheets. Spreadsheets are easy to mess up. So get a feel for how it works, run through it, see where these numbers come from. For instance, this is, it looks up the length, the weight of the bar, and etc. Well, this is the total bar, the mass itself. So it just firstly says, is there text in this first thing? So if there's no text, it doesn't work it out. Then it's the mass per kilograms per meter multiplied by the length, by 1,000 just for meters. So this works out. This is a mass per meter times by length converted to meters, and this will give you a tonnage. And then that number in the bar is just transferred to either the Y column or the R column, depending on whether it's which bar it is. And yeah, and that uses lookup functions as well, or if functions. And there you go through. You'll go through the whole thing. You'll size it all. You'll get the dimensions. You'll enter it here. Then once you're finished, let's say now the schedule's finished, we select the whole thing. Press copy, Control C. We go into our schedule. We want to paste it in here. We press Control V, paste, and click it. what it does, every second time, for some reason you paste it in AutoCAD, it doesn't ask you the size of the text, but here we go. I'm going to press Ctrl-C again. There we go. It says, what size font must we make this? What I found out that the size font, the size 11, if you take it as a text height of 140, it more or less fits, sometimes a little bit more, like there, 145. You just click and drag, you stretch it, then you move this in place. Click on it, you go home, move it up to the top. I'm going to match the properties as the same as the outside. And there we go, there's our schedule. You go fill in things, make sure everything's correct. You fixed your mistakes, you've highlighted it, you've gone through, checked your tonnages, checked your quantities, etc., etc. Then when you're ready to print, you can turn off this layer to see what it looks like. And then it's ready to print. Make sure you've updated your kilograms. If there's revisions, you change your revisions and how you explain carefully what's happened on this revision. Let me just see if I can actually find a good one that shows you what a revision looks like. So revisions, one problem with it, once you've got something that has been revised, is the rebar may already be on site. So you need to very carefully explain what is new and what is old. Here we go. This is just done by hand. I realized that I need to point this out clearly. New tie links to be ordered. So you add that. If you're short of rebar or there's a change or something, then make sure you highlight it. And another way to do it, I think it's in these schedules, is you put a big note, do not reorder these bars. So you have something, all bar marks above have been previously ordered, do not reorder. So they know that all of those, the top bars, are on site, or should be on site, so they mustn't reorder them. So if you issue this revision, they might order the whole schedule again, and double of the top schedule on. So that, and then they will now deliver only the bottom part, well, hopefully, to site, and then you can fix those. So that gives you an idea then of how you go through a bending schedule, how you create it, some general tips and tricks. There's a lot more that you need to know to be able to detail accurately and effectively. I'd say go on a Rebar course, you get experience on site, go have a look at how things fit together, what practically works, what doesn't work. Look at old bending schedules. But that at least gives you a feel of how to do a basic schedule in AutoCAD. Now, because you can get more and more complicated, you can add in various things with the schedule, you can just update it as you need. You can then create entire schedules where the schedule at the top just covers the whole page, and then you issue this with a layout. As I showed you earlier, there was that one big layout. So you issue this and you just have then a couple of A4 pages with all the bars. And that way you can go through and produce something that the contractor can use. So I hope this has been informative. I hope this helps you understand how you do a basic schedule. This is just the basics. Obviously you need to know how to use AutoCAD, but more importantly you need to understand how Rebar works and how to put it all together. And from this, hopefully we can produce better schedules in this country with help of the guys on site and produces more accurate schedules. There's various other criteria that you should look at when doing bending schedules. Lap lengths, cover, all sorts of things, but they can't be covered in this lecture. But for now, I hope you enjoyed this and hope you learned a lot. Cheers.